Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to continue looking at negative exponent properties, and this time we're going to look at the quotient to a negative power property. So let's go ahead and get started on that. So as you know, if you've been looking at prior videos, you know that when we're dealing with negative exponents, we have this basic principle that a to the negative n is the same as 1 over a to the positive n. That is the basic principle. But this time we're going to look at something slightly different, a quotient. In other words, this time our base, if you will, is going to be a fraction and not a whole number. So let's go ahead and see what this looks like real quick. So this time we have 3 over 4. Of course, it's going to be in parentheses, to the negative 2. Now, if we follow the principles that are in our negative exponent here above, that will translate into the following. This is going to be the same as 1 over 3 over 4, not to the negative 2, but to the positive 2. Now, let's work this out so that it's clear exactly what's happening so that we can understand here. So I'm just going to draw a little separation here so we don't get confused over what's happening. Change the color slightly. And so when we have 1 over 3, 4 to the square, it's really what's happening is we have 1 over 1 divided by 3 over 4. And this, of course, is squared. Now, I know that writing 1 over 1 is kind of weird, but I just want to do the full process and not make any shortcuts here. So, as you know, whenever we have, what do you call this? A fraction, whenever we divide by fractions, we flip the second one. So what we end up having here is we have 1 over 1 still, this time times, then inside here we got 4 over 3, notice how we flipped it, squared. And so, 1 over 1, that's useless. That's just 1. We ultimately end up with, let's see here, 16 over 9. Now, you're probably thinking, hey, wait a minute. What's going on here? This is not the same number. If everything works out according to plan, it shouldn't be quite like this. But here's the trick. If you square root the 16, and if you square root the 9, you get 4 over 3, which is what we started with, basically. And so that's kind of what's happening there when you square. But here's the ultimate point here, and this is going to be on the next screen. We started with 3 over 4 to the negative 2, but we ended up with 4 over 3. Basically, if you square it. I should have put the square on the previous screen, so that's what I should have put here. I got the same thing. That's what I meant to do. And so this leads to the point. This is kind of what the quotient to a negative power property means. If I'm going to write it in terms of an expression algebraically, let's see here. So when you have a over b to the negative n, it equals the same as b over a to the positive n. And if you look at our example above, that's exactly what we got here. Now again, originally I got 16 over 9, but if you look right here closely, I got 4 over 3. But if I simplify it, I get 16 over 9. But again, if you square root, if you send it back, you get this again. And that's what we end up happening. Okay? And so we started with 3 over 4 to the negative 2, but we ended up with 4 over 3 to the positive 2. That's what happens. And so this is a shortcut, again, that you can use for when you have to play with numbers and flip them around for different purposes. Now, the last thing I want to do is I want to show you an example when I'm just using variables in algebraic terms and something that's a little bit more abstract. So let's say I have x to the y to the negative 3. That's not that deep. Now, keeping with our ideal of the negative exponent property, this is basically going to end up being 1 over 1 divided by x over y to the positive 3, like so. And of course, now you have to flip it. And so you basically end up with, over here, I'll put it right here, y over x to the third, like this, like so. That's what you end up with having there. And so if you really want to simplify this even further, you could say y over 3 x to the third power. Again, notice how all we did was flip. This is basically our answer right here. And if you want to simplify, we might use this guy down here. But notice how these two are essentially the same thing. X to the y to the negative third is the same as y over x to the positive third, or to the cube, if you will. And that's how the quotient to a negative power property works. And so again, in a practical instance, this isn't always useful, but however, when you're trying to solve problems and you're trying to work with things, this can be very valuable in terms of manipulating values for other purposes. So just to kind of wrap up and make sure everything is clear, when you're dealing with fractions that are raised to a power, to a negative power, often what you can do is you use the reciprocal, so like in this example right here, and then you change the exponent from being a negative value to being a positive value. And this, again, like I said, it can be very valuable in different situations. So I hope this was useful for you. I want to thank you for watching, and we look forward to seeing you in future videos. Take care.